Hi, Isabella. All right. We're on classwork 171. Our objective is to complete the problem set. So I can't say it's one thing because it's all the things. Problem set of lesson 63. Okay? And what I'm going to do is do what I think are the more difficult ones with you. Sound fair? So that you're left to do the ones that aren't as difficult by yourself. Say what? I'm sorry, page 450. Let's see what's in the frame there. All right. So we are going to be out of order. I would like to start with number 5.
Should we need our book open?
Yeah. I'm on page 450. Okay, number 5 says, yesterday the hiker began hiking at 2,850 feet above sea level. Climbed over a 5,575 foot summit and descended 2,695 feet before stopping for the night. What was the hiker's net gain or loss of elevation during the day? All right, let's draw a picture. What do you think? We've got a mountain. Okay, we're up already. We're at 2,850 feet. My goodness, it's been a long day. Okay, this is where he is right now. Okay, he climbs up to a summit of 5,575 feet. Does everybody know that the summit of the mountain is the top? Okay, like the summit of Mount Everest is like the peak of Mount Everest. So they say I climbed to the summit, I climbed to the highest point that I could climb. It might not be like a little pinprick top. It's usually not. They're kind of rounded off at the top. Okay. And then he descended to 2,695. Is 2,695 less than this?
Yes.
So this picture is going to go down a little bit. 2,695 feet. Okay, does that make sense? Does the picture make more sense than the words? Because I believe it does. All right. What was the hiker's net gain or loss of elevation during the day? So, really, what we could do is, did he end the day higher or lower than where he began? Lower. So do we need to find this and then find that? No. What could we really do? I could do this. Do you agree? Because he went down lower altitude-wise than he was originally here. Does that make sense? So 2,850 feet. All right? What's the difference here? What is that? 155 feet. So he had a loss of elevation of 155 feet. So he ended the day. Yes, Joe?
Oh, what do they mean by net?
Net positive.
Oh, okay.
Or not net, net?
Does net gain or loss? I don't know what they're trying to say there.
What are they trying to say there? I have no idea.
Maybe he's the net
net gain or loss of elevation during the day? The total change in elevation between the beginning and the end of the day. So so the total change of elevation? That's a goofy question. It's really just supposed to be integers. It's supposed to be, we're going with this. All right, he ended the day 150 feet lower on 55 feet. Ended the day 155 feet lower than he began. He began. Does that make sense? And we just drew a picture. You don't need to write. I drew a picture to find my answer. I got it. Okay. We're going to look at number 8. Are we okay here? Convert inches to meters. We can multiply the number of inches. Use the fact to convert 1 yard to meters. 1 yard. Holy cow. That's crazy. 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 Are you okay here? I think let's just, I think 1 yard that, okay, here we go. We want to convert, what do we want? Meter, 1 yard to meters. 1 yard is equal to how many inches? 36 inches. Okay? 1 inch equals 2.54 centimeters. So how could I write a ratio for this? What? Okay, tell me what my units are going to be in my ratio. Centimeters and inches. Does that make sense? So we're going to have inches is to centimeters as inches is to centimeters. Does that make sense? This is going to be my conversion. So 1 inch is equal to 2.54 centimeters. As 36 inches is to X amount of centimeters. How do I solve that? Joe?
2.54 centimeters times 36.
Yeah, I'm going to cross multiply. Does that make sense? So 2.54 times 36. Go.
I got 9,140. Sorry.
No, you're fine.
9,144. Oh, yeah.
That looks better. It would look rather suspicious if we had 9,000 inches in 30 or 9,000 centimeters in 36 inches. Does that make sense? Are we okay there? No, 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 yes, yes, yes?
Yeah.
So 36 inches is the same as 91.44 centimeters. All right. You did not need to use scientific notation there. It's not necessary. All right. Show this addition problem on a number line. Let's just do this addition problem. So this is number 11. I've got -3 plus 5 plus -2. And we're going to get back into integers, I'm pretty sure, next week. All right. Okay, we can do it on a number line. Okay. Ready? I start at 0. I go up and I go down to -3. 1, 2, 3. Right? So this is my -3. I go up, I move positive direction 5. 1, 2, 3, 4, 5. Add -2. I go up and I go negative direction again. 1, 2. What do I get back to? 0. So this equals 0. Now, let's think of this because I don't really want you dependent on drawing this on a number line, and I think it's actually easier to think of it as money. Does that make sense? You ready? You borrow $3. Okay? You go babysit for an hour and they pay you $5. Does that make sense? You buy something for $2. So how much do you have after this? You pay somebody back your $3. Does that make sense? You got $2 left. Then you buy something for $2. How much you got left, George?
$3.
No. I know. I don't know what you were looking at, George, but you weren't looking at me. Let's start again. George, you borrow $3 from Trisha.
Yeah.
You water your mom's garden. She gives you $5. You pay Trisha back. How much do you have?
$5. I'm sorry.
You say, hey, Trish, I need $3. I'll pay it back. Okay?
Oh, like $8.
Hold on. Hold on. Hey, Trish, I need $3. Okay? So Trish says, I love you, George. Here's your $3. But you got to pay me back. So you water your mom's garden. Your mom gives you $5. After you pay Trisha back, how much do you have left? Yep. Then you go back to, yeah, now I'm positive. Does that make sense? Then you go back and say, I need to buy a liter of Coca-Cola for my brother Mark for $2. And how much are you left with at the end of it all, George?
$1. Or $0.
How about 0? Should we do it one more time, George?
No, I'm good.
Are you guys?
Yeah, I
Are you okay?
Wow.
Okay. Oh, George, what would we do without you? All right. Let's look at, we're definitely looking at 13. Okay, why don't you redraw that table on 13, please?
What table?
On number 13. Don't you have a table?
Oh,
Input,
yeah.
output? Yeah. Okay, draw this, and then I'm going to tell you how I want you to do it. Just draw like what I have on the board. Don't put any numbers in here yet.
Oh, oops.
Sorry. Can you please number them in numerical order? 3, 6, 12, 15. Now, be very careful. What's across from 3 in the table is 1. What's across from 6 in the table is 2. What's across from 12 is 4. What's across from 15 is 5. Does that make sense? Okay. Now, we are saying, what do I do to x to get y? What do I do here to get this? So y equals is always going to be where we begin. Write that down. All right, Felicity, what do you got?
You divide it by 3.
Yes. You're going to have x. This is x. X is divided by 3. Does that make sense? Or you could write y equals x divided by 3. How do I get from left to right? You're always going from your input What do I do to get my output? This is like the function machine. Okay? I put in a 3, I get out a 1. How did I get that?
3
Divided by 3. All right, let's try it for 6. I put in a 6, I get out a 2. 6 divided by 3 equals 2. Does that make sense? All right, I put in a 12, I get out a 4. 12 divided by 3 equals 4. Makes sense, right? So this is the function machine, this is the table, this is the function. Okay? And we could continue this table on down to infinity. All right? Let's look at number 14. That's a fun one. All right, a deck of cards. Somebody read that out loud really quick while I read the board. Go, Joe.
A deck of 26 cards has one letter of the alphabet on each card. What is the probability of drawing one of the letters in the word math from the deck?
Okay, ready? Here are my 26 cards. Let's go ahead and draw our 26 cards. I'm just going to draw a box. And then I got one card hanging out over here.
Times 26 next to it.
Well, I'm going to draw all my letters. Does that make sense? Sorry, Isabella, this is number 14, if you didn't hear me say that before. All right, so let's write a probability statement. The probability of choosing letters M, A, T, H, let's see, is equal to what? What is my denominator here?
26.
Yeah, it's equal to 26. Sorry, I'm writing it there so hopefully it stays in the frame on the iPhone. Okay? So, I have A, I have M, I have T, and I have H. What's my probability that I've got this deck of cards and I'm going to get one of these 4 letters? Joe?
One of them?
Yeah,
4
Any
out of 26.
4 out of 26. Can I reduce that
Yes.
to what?
213.
Yes, good. I want to hear your thoughts. All right. That doesn't really give me, I don't know, 2 out of 13 chances. So if I try it 13 times, okay? So listen, I've got, we have decks of cards down here. You guys are, some people are obsessed with playing cards right now. You get your decks of cards out, you spread them out on the table, okay? You pull out a card. You have 13 tries, but what this says here is you put your card back each time, okay? As opposed to, so it's called replacement. If you didn't replace, then our probability would be completely different, okay? But we're replacing our card each time. So I have 13 tries. If I try it 13 times, theoretically, 2 of the times I should get one of these 4 letters. Interesting, huh? What's 2 divided by 13?
6.5.
6 point, sorry,
2 divided.
2 divided by 13 is 15.4, so 15.4%. That gives me a better idea. So if I did it 100 times, 15.4 of the times I would get my math letters. All right. I want you to redraw that triangle that's right there below this question. Redraw that triangle. All right, and let's go ahead and label. It says A, B, A, D, D, B, D, and C, D. All of them are equal to 5. So this is 5 centimeters. That's not 5 centimeters. This is 5 centimeters, right? Yeah. 5 centimeters, 5 centimeters, 5 centimeters. And this angle is 90 degrees. Okay? All right. Classify triangle BCD by its sides. What kind of triangle is that, Isabella?
Oh, scale.
Hang on. BCD. This triangle right here.
Oh, isosceles.
Yeah, it's an isosceles triangle. George, why is that an isosceles triangle?
Which one, sorry?
The green one.
ABC? Because the sides, they have 2 congruences.
Good job, George. I wasn't sure if that was going to come out there, George. All right. Same. What is the perimeter of the equilateral triangle? Tell me, what is my equilateral triangle, Holland?
ABD.
Good. All right, what's my perimeter of my equilateral triangle, Sarah? What's perimeter?
15.
Yeah. So I add up the sides. I add up the sides of my equilateral triangle. It doesn't say ABD, but we just said that. So 15 centimeters. Do I have centimeters squared or just centimeters normal? Normal. Okay? Not squared because it's perimeter, not area. C. Which triangle is a right triangle? Joseph?
BCA.
BCA. Yep. Triangle BCA. You could say triangle ABC. You could say triangle CBA. You could say triangle ACB. Any of those. It's this big triangle right here. Right triangle. Ooh, this is a good one. All right, 16. We're using the same triangle. All right. It says, find the following angles. All right. What angles are the easiest ones to find here? Joe knows. Joseph knows. Felicity knows. What do you think, Felicity?
It's the right.
Okay. We've got a 90-degree angle here. Okay. What else do we have? Felicity?
An acute angle.
I know, but I need angle measurements. Okay? Joseph?
45 degrees.
Where?
On the C and the A.
On the C and the A?
Yes.
I can't assume that. Joey?
Wait. Oh, never mind. It's kind of. I thought I saw one other right angle from here. But
I don't have any more right angles.
no, from here, just kind of there.
Oh, okay. Let's think. What do we say about letter B? What do we know about this triangle right here?
That the perimeter is 15.
Okay. Before I knew the perimeter was 15, what do I know, Isabel?
That angle is 90 degrees.
Only that part. Remember, there's a black line. All right, I'm talking about just the triangle. Just the triangle. Joey's dying over here.
It's equilateral.
It's equilateral. What do we know about an equilateral triangle? If it's equilateral, Holland, what else does it have to be?
All the sides are the same.
Okay. And if all the sides are the same, what about the angles? Good job, George. The angles are all the same. So, in order to have the angles all be the same, what does the measurement of each angle need to be? Joseph?
60.
60. Because what do all three of the angles add up to be? Just say it.
180.
Oh, thank goodness. Okay, so this is 60, this is 60, and this is 60. All right, now we can do some serious adding and subtracting. You ready? If this whole angle is 90 and this part is 60, what's left over?
30.
30. Does that make sense? Do you remember that? Does that make sense? All right, if this angle is 60, how much does this whole line equal? 180. So if that's 60, the whole line, the straight angle is 180. What's left over?
It just keeps that line.
Oh,
120. Now that line, I keep on. It looks like it's a right angle to me. So
I'm sorry, my drawing is not good. So that's 120. Okay, how much do all three of these angles of this triangle down here add up to? 180. So 180 minus 120 is what?
160.
Okay, minus 30 is what?
30.
So this angle is 30.
So what does it mean? So for 16 was A for BAC. What would be the angle for that?
So angle BAC is 60. Make sense? Angle DADB. ADB is 60. Make sense? No, Joe? So they're just naming the angles. We've named angles, been here before, right? So angle BAD. BAD is this angle right here. Does that make sense? No?
it does.
No?
It does.
Okay. You guys are looking at me like I'm crazy. And maybe I'm saying my letters wrong, or maybe I have something on my face. I don't know. You're looking at me weird. Do I have something on my face? No, I'm very healthy. Okay. All right. Angle. So that's letter A. ADB, angle ADB, ADB is equal to 60 degrees. Angle, oh my gosh, it's BDC, BDC is 120. DBA is 60, DBC is 30, DCB is 30. All right, let's think. You do not have to do 29. You do not have to do 29. Okay? Hopefully I took care of most of the really difficult ones. Now, I know it is daunting that we're going to do these 30 problems. Okay? Daunting. I hope it doesn't take you more than a half hour because I hope I did most of the really difficult ones. If you are working for a superbly long period of time, I want to know that. Okay? The only way this book is going to work is if we do all these practice problems because they didn't do practice. These are the practice problems that go along with the lesson. It's just how this book is designed. Next year, don't worry, you're in a normal book. Okay? All right, let's pray. Say, we hope you feel better, Isabella.